Hello scholars, time for another exciting installment of Module 3 Notes, Extra Practice. We're going to do another word problem together. I will write it down. I would like you to copy it down as well so you have the problem. It's not a terribly long one to write. We'll go ahead and work it out together. For this problem, a gentleman named Jackson started off his day. Jackson had 1 3/8 kilograms of fertilizer. Stinky. 1 3/8 kilograms of fertilizer. He used some of it. Now they're not telling us how much, so that's important to note. He used some to fertilize a flower bed. Now again, it says some. We don't know how much. He used some to fertilize a flower bed and had 2/3 of a kilogram left. So we know what he started with. We know he used some and then had this much left. So the question, as I'm sure many of you have already guessed, how much fertilizer was used in the flower bed? Whoops. Let's make this legible. So we need to try to find out exactly how much was used in the flower bed. To start this off, I am going to draw a tape diagram. Now this is not something that I am going to break perfectly into fractional pieces. We have done that before where we break something into eighths or thirds or whatever. That's not what this is. This is just a tape diagram to show us and help us visualize the entire flower bed. So here's the whole thing. Okay? And actually, let me be careful there, because I said visualize the flower bed, but really, for shame, Mr. Landre, get those question marks. What we're really trying to see is the fertilizer. This tape diagram is going to represent all of the fertilizer. All of the fertilizer. 1 3/8 kilograms of fertilizer. In fact, I can even put 1 3/8 kilograms right here. Okay? 1 3/8 kilograms. He used some for a flower bed. I don't know how much. Some for the flower bed. And then had 2/3 of a kilogram left over. So if this whole tape diagram represents the 1 3/8 kilograms he started with, and we know he had 2/3 of a kilogram left over, we need to find this. And the best way to find this is to take this part away. When I am trying to take away, when I am removing something, I am subtracting. So this is the basic expression we're going to work with. Now, we've talked, there are a couple different ways we can do this. We can get up, get down. We can find least common multiple. I will do least common multiple, and I'll do get up, get down, so we can see both. But I get ahead of myself. Right now, I have a mixed number minus a fraction. That's kind of tricky to work with. I want to turn this mixed number into an improper fraction, then I'll have two fractions. 1 3/8. Well, 1 whole, if it had the same denominator as this, 1 whole would be 8/8. 8/8 plus another 3/8 would be 11/8. Another way to visualize that, multiply across the bottom. 8 times 1 is 8. Then add across the top. 8 plus 3 is 11. Now I've got two fractions. I'm going to write them a little bit bigger down below so I've got more room to work. Okay? But these fractions are equivalent to this, which is equivalent to what I was working with there. So let's go ahead. I'm going to put 11/8. Like I said, I'm going to write it a little bit bigger so I have more room to work. 11/8 minus 2/3. Now I wrote them vertically, so you can probably guess I'm going to go ahead and do LCM, least common multiple, first. Least common multiple. Eighths, thirds, these are not the same. I cannot subtract if I have unlike denominators. So 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. Normally that's far enough, but spoiler alert, it will not be this time. 8 times 1, 8 times 2, 8 times the other number, 8 times 3. Now once I have multiplied the two of them together, if there's nothing smaller that matches, and there isn't, that's your LCM. I'm going to go ahead and list the rest of them out so you can see that I am not fibbing to you. 24 is the first number that shows up in both lines. So our common denominator is 24. This is our least common denominator. We need to write equivalent fractions over 24. 8 times something makes 24. 3 times something makes 24. Okay. 8 times, well, 1, 2, 3. 8 times 3 is 24. And if I multiplied the bottom by 3, I must multiply the top by the exact same thing. 11 times 3 is 33. Improper fraction, just like we had before. 3 times, well, again, we know already. 3 times 8 equals 24. 2 times 8 is 16. Now I can subtract. 33 minus 16. Again, sometimes it's easy, at least for me, to just kind of draw a little line to help me visualize. I'm focused on just these right now. 33 minus 16. I don't have to worry about the denominator. It's going to stay the same. It's really just a label. It's showing me how many pieces I need for a complete set. 33 minus 16. Well, 3 minus 6 won't work unless I borrow. 13 minus 6 is 7. 2 minus 1 is 1. So, when I subtract 33 24ths minus 16 24ths, I get 17 24ths. How much fertilizer was in the flower bed? How much was in this mystery spot? 17 24ths kilograms in the flower bed. Getting a little close to the end there, but I will still box up my answer because it just looks so nice. Okay. Now, that was solving with least common multiple. I'm not going to go through and solve the entire thing again, but I will show you just as a quick refresher. Let's go back to this. 11/8 minus 2/3. If I wanted to do get up, get down, I would end up with the exact same numbers I just subtracted. I get up, 8 times 2 is 16. I get up, 3 times 11 is 33. And then I get down. 8 times 3 is 24. 33 24ths. Ding, ding, ding. 16 24ths. Ding, ding, ding. So again, I would end up with the exact same thing. The nice thing with least common multiple is sometimes you end up with slightly simpler fractions and you have less simplifying to do. This is a good example because you don't have to really simplify. Whatever strategy you use, you get the same fractions. But be aware, if you like get up, get down, it is a lot faster, but you may have to simplify at the end. This time you don't. This time you don't. All right, so that is just one more example. I guess 2 examples of how you can solve one of these word problems. Please make sure that when you have these word problems, you're reading them carefully. Consider using a tape diagram. It doesn't have to be broken up into fractional parts. You can just split it into what I know and what I don't know. How do they combine together to make my whole? Sometimes this will show when you need to add. This will show when you need to subtract. But that's where we'll go ahead and end for today. As always, please make sure that you bring your notes to class with you. If you have any questions, bring those to class with you as well. All right, thanks, folks. I will see you soon. Have a good one.